All right, so the next principle which I want to show you is the interface segregation principle. And for this one, I'm actually going to do a bit of a synthetic example because essentially the interface segregation principle is something that you are likely to encounter in the real world where you're just building interfaces which are too large. And the idea is quite simple, that your interfaces should be segregated so that nobody who implements your interface has to implement functions which they don't actually need. So let me give you an example. Let's suppose you have a document and you want to do different things with the document. So you try to emulate some sort of printer or scanner, but there is also this thing called a multifunction printer, which does both the printing, the scanning, as well as the photocopying as well. So you decide, oh, I'll make an interface for everything. So you build one big interface called iMachine. And this iMachine interface does all things. So it can print the document. So I can print the document as soon as I learn how to spell, that is, print the document D, and it can also scan the document. So you can scan, and you can maybe fax the document as well. So you build this kind of interface, and this interface works just fine so long as you're actually working with a multifunction printer. So if you have a multifunction printer, then everything is fine because you implement this iMachine interface. You go ahead and you implement the members, and then you can do something for each of the members because the thing can in fact print, it can in fact scan documents, and it can also fax document, for example. So this is okay, but then you go ahead and you decide to make just a good old-fashioned printer. Old-fashioned printer. It cannot scan, it cannot fax documents, anything like that. So the problem is that you've only got this one big interface with lots of responsibilities attached to it. So what do? I mean, you have to implement this interface. So you implement the interface, iMachine, you implement the missing members, and certainly implementing the print function is obvious enough. You have a printer, so you implement print. But now the question is, well, what do you do about the scanning and the faxing? Do you throw an exception? Do you do a no-op? Do you maybe output some message that this operation is not supported? I mean, the operation is kind of undefined a little bit, especially for the consumers of your API. So you would have to really document that your old-fashioned printer, even though it implements the iMachine interface, it does in fact only supply the implementation of print and does not supply the implementations of scan and fax. So that's a bit of a problem, and that is where the interface segregation principle comes in. So the idea is to make sure that people don't pay for things they don't need. And this means that if you don't need the scanning and the faxing, then those things should be separable somehow. And instead of having one big interface, you should have lots of smaller interfaces which are more atomic, shall we say, in the sense that they are kind of self-contained and they cover a particular concern. So what you would do in this case is, of course, you'd make a lot of smaller interfaces. So for the printing, you would have an iPrinter interface where you would have the print function. So this would work on a document. And similarly for the scanning, for example, you would have the iScanner interface, and this would have the void scan function. Again, on a document or into a document in this case. And then, of course, if you want to start implementing these functions, then you can, and there are different ways of doing it. So one is if you are making a photocopier, for example, then you might want to implement just both of these interfaces. So if you have a photocopier, for example, then you might want to have the iPrinter interface and also the iScanner interface, and then you simply implement all the missing members and you actually provide the appropriate implementation. Or, of course, if you do want a higher level interface as well, like a kind of multifunction device interface, you can have it as well, because interfaces can inherit from interfaces. So you can have an multifunction device, which is actually an interface which is both an iScanner, iPrinter, and other things as well. So you can have other interfaces here. And then, of course, when it comes to actually implementing this interface, once again, you have different options of doing it. So one way would be if you have a class called a multifunction machine of some kind, you can just go ahead and you can implement this multifunction device interface. So that's one approach. And how you actually implement this is completely up to you, because, for example, if you already have the implementations of a printer and a scanner, and you're saying that a multifunction device is simply the joining of those two classes, concrete classes that you already have, then you can do delegation. And in this case, you would implement the missing members, or rather you might not implement the missing members. What you can do instead is you can suppose you already have a printer and a scanner implementation some way. You can have, for example, an iPrinter called printer and an iScanner called scanner. And what you can do now, thanks to the magic of ReShopper, is first of all you can make a constructor which actually initializes both of these. And then, of course, what you can do is you can delegate the calls to each of the interface methods of iMultifunction device. You can delegate them to the printer and the scanner respectively. It's the decorator pattern in actual fact. So what you can do is you can go in here into the generate menu. You can choose delegating members and just select all the members. And so print will be delegated to printer and scan will be delegated to scanner. So here it is. So we've auto-generated the implementations of the iMultifunction device interface, and we're actually delegating the calls to the calls of the inner printer and scanner variables, a classic example of the decorator pattern. So this is the decorator. So this is the interface segregation principle, a basic idea that if you have an interface which includes too much stuff, then just break it apart into smaller interfaces.